Hello everyone. In this video we will talk about planar kinematics of a rigid body. So first, the angular velocity is the derivative of theta in terms of time. We have it here. And then we go to angular acceleration, which is alpha, which is the derivative of the angular velocity in terms of time. And now we have those equations, alpha d theta equals w equals omega d omega. Now these look very familiar to when we were using regular translation motion, and if you remember those from before, we have these three equations to solve the problems. Now also, I don't know if you remember, but these look very similar to v equals v naught plus at, and then s equals s naught plus v naught d blah blah blah. These are the same equations except we're replacing v with omega, the s with theta, and a with alpha. Now let's keep going. Next, let's say we have a circle or a wheel or whatever. We have the center O here, radius r. Let's say this is point B, and we have this tangential velocity v over here. Now v equals omega, which is the angular velocity, times r. Now notice, because this is perpendicular, the original equation is vector v is omega cross product r, and then tangential acceleration is alpha r, normal acceleration is omega squared r. And so both these equations, this and this, they came from these two. So vector A is equal to AT plus AN, and A is alpha cross product with R minus omega squared times R. Now notice omega squared is actually, this is a value, not a vector. R is a vector. Now let's go into relative motion. So if you remember from the previous chapter, we have VB equals VA plus VB with reference to A. We also have RB equals RA plus RBA. Now these are vectors. And so introducing the rotation, we get VB equals VA plus omega cross product RBA. This is very simple. Now let's use this in this example over here. We have this length, we have this part A, we have B. Now A is moving downwards with a velocity 2 meters per second, which is going to cause B to move this way. Let's say we have the length from A to B 0.2 meters, B to C 0.1 meter. Now we want to know what is VB at theta equals 0. This is theta. Theta equals 45. So first, let's use the equation that we saw earlier. We know VB equals VA plus omega cross product RBA. Now we know VB is only going to be moving in the I direction because it's constrained over here. So we have VBI, that's the value of VI, equals VA, which is minus 2J, omega, which is omega in the K direction, cross product with RBA. Now RBA, we go from A to B, so we have minus 2 sine 45I, which is this distance from here to here, and sorry, that's positive because it's this way, and then minus 2 cosine 45J. This is from here to here. Now we do the cross product, we get VBI equals minus 2J plus 0.2 omega sine 45 plus 0.2 omega cosine 45I. Now notice, we have I here. Thus, we can only equate VB with the I term over here. So we have VB equals 0.2 omega cosine 45. Now that leaves us with these having to equal 0, so we have this equation. Correct, right? So we have these two. Now we have VB equals 0.2 omega cosine 45. We don't know omega, we need to find it. We can use this equation to find it. So from this, we get omega equals 14.1 radians per second, and plug in this in here, we get VB equals 2 meters per second. Now, let's talk about instantaneous center of zero velocity. Now the instantaneous center is where the velocity is equal 0. So this can be used to basically, instead of using VB equals VA plus omega blah blah blah, we can use VB equals VIC plus omega cross blah blah blah. And we know VIC is 0. This is very useful. If you don't want to go ahead and find this extra velocity, which is VA, we can just find where the location of VIC is, and then we can simply remove that value. Now, how do we find the location of VIC? Let's say we have this link. We have A over here and B. Let's say VA is as such and VB in this direction. Now the way to find it is you elongate a perpendicular link to VA, crossing A, and the same to B. The intersection is where IC is. This should be very simple. Now, I would recommend actually using this method to solve even the previous problem or any problem. It makes it very simple, and you have less chance of doing mistakes this way. Now let's move on to acceleration. So this is a continuation to velocity. We have these two equations for acceleration. AB equals AA plus ABA tangent plus ABA normal, which leads to AB equals AA plus alpha cross RBA minus omega squared RBA. Now let's do an example on this. Let's say we have this wheel over here. It's rolling with an angular acceleration alpha, angular velocity omega. We have radius r, center G, and point A over here. Now I want to know what is VG, what is AG, and what is AA. Now notice, first thing to note that VG is going to be going this way. So let's set the equation. VG equals VA plus omega cross RGA. We know VG is only in the I direction. The wheel is not moving upwards, it's only moving in the horizontal direction. So VA is 0, that's the instantaneous center. You can elongate here, you see it crosses here. 0 plus minus omega k cross RG. So VG is omega r. And AG is dV dt, which is d omega dt r. So we get AG equals alpha r. Now we want to know the acceleration at A. We set the previous equation that we saw, and then we get AG is basically from what we found over here. We plug it in here, we get alpha Ri, and then equals AAX. We separated AA into X and Y component. That's AAY minus alpha K cross RG minus omega squared RG. Now AAX is 0 since that's the IC. So we get, now we equate the J term. What do we have for the J term? We have this, and we have this. Notice this gives us I. So solving this, we get AAY equals omega squared R. Now, the last thing we will talk about is rotating axis. So this is when, let's say we have a link. This is rotating, and also we have a bar over here that's going in both these directions. So here notice we have a rotating axis. This is not fixed on the link, it's moving in this direction. So the first equation is RB equals RA plus RBA. This is, we saw that originally. Now we're interested in VB and VA. So it's very similar to before, just VB equals VA plus omega cross RBA. Now notice this is, before it used to be omega like this, now we're using this to differentiate, cross RBA, and plus, notice we added this term, VB with relative to A. XYZ is just a notification. And AB equals AA plus omega dot. This is the angular acceleration. Plus omega cross RBA. Now notice we do this first, and then we do the whole thing. Plus 2 omega cross RBA XYZ plus ABY XYZ. Now this is the same equation as before, it's just we added these terms. This basically sums this chapter. Thank you everyone for listening.